Welcome to the ET 335 Boolean equations lecture presentation. Here we have the logic expressions, the Boolean logic expressions for an AND gate. AND gates are represented by multiplication. Okay, and if we go through the multiplication, we're going to get our truth table. So here's our AND gate, and we have A and B input. So we're going to have X as the output equals A times B. And we could put the multiplication, or we could use parentheses, or we could just butt these two up against each other. Okay, our 3-input gate would be X equals A times B times C, and our 4 would be X equals A times B times C times D. Here we have an OR gate, and if we go through and add everything up, so when we're using an OR, we're going to use addition. So if we add these up, we're going to get our truth table. And here's our OR gate with inputs A and B. So our output X is going to be A plus B. 3 input would be X equals A plus B plus C. And 4 inputs would be A plus B plus C plus D. So OR gates are addition. Here we have the Boolean logic expression for an inverter, and it'll be called a NOT. So what we have here, anytime that we have a bubble or an inverter, X equals a bar, and the bar must be over the entire element. Here we have the Boolean expressions for NAND gates. So a NAND gate would be an AND and inverted. Okay, and if we go through the truth table, we see the bar. Okay, so a NAND gate with A and B inputs would be X equals A, B bar. And you notice the bars over both of them completely. Okay, so anytime we see a bubble, we need to bar the entire expression that's represented. So a 3 input would be X equals A, B times C with a bar. 4 would be A times B times C times D with a bar over the entire group. Here we have our NOR gate expressions in Boolean. So we notice here that we have an OR gate with a bubble that would make it a NOR. So our bar would be over both elements. So X equals A plus B bar. 3 would be A plus B plus C bar over the entire. And X equals A plus B plus C plus D bar over the entire expression. Okay, so let's write the Boolean equations for these logic circuits. So the first one's going to be A times B. Okay, and this is going to be A times B plus B. Okay, equals X. And we can put a parentheses around these. It's not necessary, but in the future when we start breaking things up, it's helpful to keep from losing the pieces. So let's go to the next one. So we have A plus B. Here we have A times B. And over here we're going to have A plus B. Definitely use a parentheses here. And we could just go ahead and use a multiplication, or just go ahead and butt the parentheses up. Okay, there we have it. Okay, here's the CAD results, and it looks like we did a good job.